That's about what is high theta, low theta? What does that mean?
Yeah.
So maybe taking us a little bit deeper, I know that you have there's some things to know about the metals and the plates. Can you tell us a little bit more about that, Georg, please?
Yeah, absolutely. Yeah, so there's, let's say, different corrugations
Yes.
and plate types are needed in a heat exchanger. So as we see here, there's a high theta plate, a low theta plate, and you can mix both with each other, then you get an M plate, an M channel. Yeah.
What does theta mean here? I know it's a Greek letter, but what is high theta, low theta? What does that mean?
Yeah. High theta and low theta means high efficiency and low efficiency, and efficiency goes always along with pressure drop. Yeah. You can have high efficiency and a higher pressure drop, or you can have a little lower efficiency but also a lower pressure drop. So on the process demand, we can adjust by either having one sort of plates, or mixing the plates to each other. Then we form different channels, and those different channels are suitable for different process application and process needs.
Okay.
As well as, let's say here, not only the standard fishbone pattern, what we call it. Then we see also here a so-called dimple pattern. And the dimple pattern is very useful when it comes for gas to liquid application.
Oh, yeah, okay, we can see that here. You can see that looks very interesting. Okay. Yeah. So whereas we have here basically the channels going in lines, here you have them.
Correct.
How does it flow? Where's the flow here?
The flow goes actually, it's distributed along the plate via the different.
So it kind of like just fills up this area and then flows through here.
And it flows through here, and these are so-called baffles, what we have in here. Yeah.
Okay. Is this the kind of thing we would see in this object we have here on the table?
Absolutely.
This one has dimples.
This is exactly that gas to liquid.
This has dimples.
Yeah, this has dimples.
How sweet. Okay.
Another point is the asymmetry, as we see it here, in this nice sketch.
Yes.
What is asymmetry? Asymmetry is, let's say, a different volume on different sides. Yeah? With a symmetric standard heat exchanger, you have on both channel sides the same volume.
Yeah. Okay. Right.
But certain applications require different volumes. Yeah? For example, the gas to liquid heat exchanger. It requires a very high volume or very large volume on the gas side.
On the gas side, yeah.
And a smaller volume on the liquid side. It's dependent on the specific heat transfer coefficient of each media. Yeah? And this is something we use here to form also different channel types.
Okay, so we see that here that the channels here, both same. Here you have the larger channels for the red medium here and the smaller ones for the blue. When we look at this one here again, I mean, I see a big opening and a small opening. So am I guessing correct that this would have larger channels on this?
Correct. That's the gas side.
Okay, that's the gas side. Okay.
And this is the liquid side.
Okay, and what would this one be used for? To mention an example of a hydrogen application?
One example can be, let's say, exhaust heat recovery coming from a fuel cell.
Yes.
That can be one example.
Okay, and so in this case, we would have the exhaust pipe coming in here.
Kind of moist air coming from the fuel cell.
Yeah. So this would come in here.
And
then
flow through here, through the channels. Yeah.
Through those, and along the dimples.
Yeah, along the dimples, right? Yeah. And then we would have here from the lower point entering the cooling media, which is water, and going upwards, because we always go co-current.
So the one goes upwards here, and the other
goes downwards.
Okay.
And then, let's say the gas is then also returned here on the outlet.
I think one don't need to say that. Yeah, exactly.
Backside
so that comes out on the other side. Okay, so now we understand exhaust here, and then basically you're taking it, so you're recovering the heat from
Absolutely.
that. Yeah? And what are these ones for?
These are the special condensate drain connections. Yeah. So when it comes to this moist air, and you cool it down, then this is also a condensation process, and water would then flow down the channels.
Yes.
Yeah, and would collect here, and you can release it here.
Yeah. All right. Yeah, very, very interesting. This one. So I know that this is one that you actually do use in hydrogen applications. Where would you use this?
In a combined heat and power system
Yeah.
for fuel cells. Absolutely, this is, let's say, the appropriate application to use such a gas to liquid heat.
Okay.